a major in physics because I didn't want to live in a world that they can't understand. And physics helps me to understand the world that we live in. Maybe you didn't notice, but we all use physics every day. When we look in a mirror or put a pair of glasses, we're using the physics of optics. When we set our alarm clocks, we track time. When we follow a map, we navigate geometric space. Our mobile phones connect us via invisible electromagnetic threads to satellites orbiting overhead. But the fascinating thing is, physics is not all about technology. Even the blood flowing through our arteries follows the laws of physics. And here today, I share my knowledge with you. If we want to understand the universe, we must start from the beginning. In his book, Stephen Hawking says that there was a famous scientist. This scientist is rumored to be Bertrand Russell. He was giving an astrophysics lecture describing how the Earth spins around the Sun and how the Sun itself spins around an enormous lump of stars called our galaxy. But in the end of the lecture, an old lady stood up and said, "What you are saying is nonsense. Our world is a flat sheet settled on the back of a turtle." The scientist smiled and laughed, saying, "And what does the turtle standing on?" She replied, "You are very clever, young man, very clever, but it turtles all the way down." It seems a funny idea how some people might think that the Earth is flat, or our shape of the universe is taking the shape of a turtle. But what do we know? And is even our knowledge true? The Big Bang have occurred about 13.7 billion years ago. Until this day, galaxies are still spinning and flying apart from each other. Just to clear things up, galaxies are not like flying debris from a bomb that has just exploded. Space itself is expanding. Distance between galaxies are increasing in a way that is reminiscent of red dots painted on the surface of a balloon that move away from one another when the balloon is inflated. It doesn't matter in which dot you reside in order to observe the expansion. Looking out from any dot, the other dots appear to be receding. But let's go even earlier. What you're going to see here is a simulation for the Big Bang. Every second here represents 22 million years. So you will have to use your imagination with me, please. In the first 100th of a second, the oldest moment that we know in the whole universe, the universe cooled down for 100 billion degrees Celsius. That's even hotter than the heart of the stars. It was extremely hot that even particles, atoms, couldn't hold their form together. Electrons is basically what forms our electricity. Neutrons, protons, was instantly created and vanished because of the heat. Actually, scientists believe that in this moment of the universe was densest than water by 4 billion times. That's a big number if you're going to ask me. 1 second after the Big Bang, the universe cooled down for 10 billion degrees Celsius. It was a lot cooler than the first 100th of a second, but not enough cool for the atoms and particles to form. Not until the first 3 minutes after the Big Bang, the universe cooled down for 1 billion degrees Celsius, allowing the neutrons and protons to form together, making heavy hydrogen. But until thousands of years later, 50,000 years later to be precise, the universe cooled down even more, allowing neutrons and protons to form together, making the first two elements in our universe, hydrogen and helium. This universe's second element, hydrogen, along with helium, dotted the universe with atomic clouds. Within the clouds, small pockets of gas may have had enough energy to cause atoms to collect. These clusters of atoms formed during the galactic epoch became the seedlings of galaxies. Nestled inside those seedlings, the stars began to form. But humankind didn't know that until recently. The first people to think about the universe were Greeks. Eratosthenes, an ancient scientist, had heard that a city south of Alexandria called Syene, located here, there were no vertical shadows cast at noon at all. So he wondered if the same phenomena also happens in Alexandria. I took these photos and videos from Hawaii, as you can see here, because the same phenomena also happens there. As you can see here, there is no vertical shadows at all. It seems like the photos and videos, like it's almost photoshopped or edited, but actually it is not. These photos are actually real, and the reason there is no vertical shadows is because the sun is directly overhead of the objects, and that's why there is no vertical shadows. So in June 21st, he planted a stick in the ground to see if any shadow would cast, and actually there was, and it measured about 7 degrees. So if the sun's rays are coming in at the same angle at the same time of the day, and the stick in Alexandria is showing shadow while the other in Syene is not, that means that the Earth's surface is curved. The Earth's surface is curved, and he probably knew that. The idea